Now we're getting to the simple machines part of our revision. The first question asks, what is a machine that is a double inclined plane? Now you'll remember an inclined plane, an inclined plane is something that is like a ramp. So this would be an inclined plane. The person walking up the hill is using this ramp, using this ramp to get up the hill. Only one side of the ramp is being used, only this upward edge is being used, therefore it's a single inclined plane. Now, we also have things like, for example, an axe head, where both edges of that ramp are being used. Therefore, that is a double inclined plane, and we call them wedges. Okay, the formula for calculating mechanical advantage, you're not going to have to do this on the test. You might have to calculate it, but we will give you the formula on the test. You don't have to remember it. Okay, this next question though is pretty important. What you do need to remember is the fact that there are 3 different classes of lever. That first class has the fulcrum in the middle, second class has the load in the middle, and third class has the effort in the middle. Remembering maybe an example of the 3 might be the easiest way to remember this. First class is a lever. First class could be a wheelbarrow. Anyway, start again. First class could be a seesaw. Second class could be a wheelbarrow. And third class could be a baseball bat. As long as you remember one example of each, you'll be fine. Now, the fishing rod, the effort is in the middle of this long lever. Therefore, if the effort's in the middle, it's third class. Third class levers are always speed multipliers. First and second class levers are normally force multipliers. Okay, number 2, the hammer. What's in the middle? The load. The load is in the middle. So a hammer is a second class lever. Wheelbarrow, load in the middle, second class lever. Force multiplier because it's a second class lever. 4, the effort is in the middle, so it's third class. Third class are always speed multipliers. And part 5, we've got the load on one end, the effort on the other end. The fulcrum is in the middle. So this is like a seesaw or using a crowbar to lift a rock. It is a first class lever and a force multiplier. Okay, question 4. True or false? A steeper ramp provides a greater mechanical advantage? No. To make that true, you'd have to say a steeper ramp is making it harder, so that's less mechanical advantage. False. A pair of tongs acts as a first class lever? No. Tongs have the fulcrum at one end. A first class lever has the fulcrum in the middle, so that's false. Mechanical advantage just means how much easier the machine makes the job. If it makes it 3 times as easy, the mechanical advantage is 3. If it actually makes it harder, the mechanical advantage will be a really small number, like 0.5 or 0.2 or something. But if the number is big, it means you get a bigger advantage. It means you've made the job easier for yourself. And there are different ways of calculating mechanical advantage depending on whether you're talking about the forces in newtons or whether you're talking about the distance from the fulcrum. Again, if you have to calculate this in the test, we'll give you the formula. Right, so using the formula for mechanical advantage, which I've written just above, or if it's in the test, we'll write it down for you, calculate the examples. You do need to know how to plug the numbers into these formulas. So if a wheelbarrow has an effort arm length of 1.5 and a load arm length of 0.5, the formula is effort distance divided by load distance, or 1.5 divided by 0.5. And I put that into the calculator. Actually, I understand that. Anyway, yeah, if you put it into your calculator, you'll get 3. Part B, you've got an effort distance of 1.2, and the load distance is 0.05. Now the reason you use this one is you have to make sure you have the same units. This is in meters and this is in meters. Therefore, you can calculate using those two. If you use meters and centimeters, you're going to get the wrong answer. Okay, so the answer is 1.2 divided by 0.05, or 24. I'm going to stop and go on with the next video.